Welcome to the Energy Rhythm Theater. Our friend, the needle-felted inventor Fox, is currently locked inside a laboratory made entirely of clay and wool, and he'll need to use physics to get out. He faces 4 specific physical barricades. To escape, he must navigate this environment using only raw materials and the laws of electricity. Right now, the lab is in pitch darkness. His inventory is limited: a few clay energy blocks, some conductive yarn wire, and several felted light bulbs. Survival in this workshop depends on mastering the specific physical laws that dictate how energy travels from the source to the light. For his first attempt at lighting the room, the fox connects 2 bulbs to the same single strand of yarn. This forces the electrical energy through one shared pathway, a configuration known as a series circuit. Because the energy must push through multiple obstacles in a row, the current faces heavy resistance. These yellow yarn spheres are squished flat and move sluggishly, leaving the bulbs with only a dim, weak glow. Beyond the poor light, this unbranching path creates a dangerous structural vulnerability for the entire laboratory. When a falling clay shard smashes one bulb, the entire circuit breaks. Because there is only one path, the flow of yarn spheres stops instantly, and every other light in the lab goes dark. Relying on a series configuration for your devices is fragile. A single point of failure destroys the entire system. To solve this, the fox rebuilds the circuit. This time, he creates dedicated, independent pathways for each bulb, a setup called a parallel circuit. This diagram shows the logic. The energy pathway splits into 2 separate loops. The current divides to conquer resistance, delivering energy independently. With dedicated paths, the current moves at full speed. Both bulbs burn at maximum brightness, no longer sharing a single crowded wire. This setup is resilient. If the fox removes one bulb, that specific lane simply closes, while the other continues to shine without a flicker. Real-world engineering relies on this exact logic. Your home is wired in parallel so that one broken lamp won't leave your entire house in the dark. The next obstacle is a massive, locked clay door. It won't budge for a standard circuit. It requires raw, overwhelming force to break the mechanism. Improving the pathway isn't enough for this challenge. The fox must now change the output of the power blocks themselves. By connecting the positive pole of one clay battery to the negative pole of the next, he wires them in series. As the diagram shows, this stacks their voltage together, doubling the total electrical pressure. Reconfiguring the relationship between these power sources allows the fox to multiply the system's brute strength. The reaction is intense. The clay blocks vibrate as hyper-fluffy, enlarged yarn spheres sprint through the wires at high velocity. The fox is now funneling twice the normal voltage into a single bulb, forcing the needle-felted filament to its absolute limit. The result is a weaponized burst of light. A blinding white beam erupts from the bulb, striking the clay padlock and shattering it into fragments. When you need to overcome heavy resistance, a series battery configuration provides the short, explosive burst of energy required to break through. With the door open, the final challenge begins: surviving a long, freezing night. This requires duration rather than sheer power. The previous high-power series setup is now a liability. Stacking the voltage drains the clay blocks rapidly, and the energy would be depleted long before dawn. Instead, he wires the batteries in parallel, connecting positive to positive. This pools their capacity into a single large reservoir, as shown in the schematic, while keeping the electrical pressure at a steady, standard level. The lab stabilizes. The lights return to a soft, breathing rhythm, and the depletion of the clay blocks slows to a crawl. These parallel power sources act as an expanded reservoir, prioritizing long-term survival over raw strength. The fox has mastered the variables. He can manipulate the path for system reliability and reconfigure the source to control both output and endurance. His laboratory is now a peaceful, warmly glowing sanctuary, operating with perfect electrical efficiency. Bending the flow and structure of energy provides the control needed to conquer the physical limitations of any environment.